Imagine that you're a space systems engineer and you're about to watch this comet lander that you've spent most of your career designing finally reach its final destination, a comet somewhere close to Jupiter. It's such an exciting moment, and you're expecting the lander to start braking slowly and then smoothly land on the surface of the comet. But instead of stopping, oh no, it bounces like a football once, twice, three times and breaks one of its two solar panels before it finally takes a halt. Oh no, this is not good. But what can you possibly do to fix it now? This talk is not about repairing stuff that we send into outer space. It's about the necessity to find design strategies that help us build flawless machines that work on the first go. So what we would normally want to do is to test and correct things in their real environment until they finally work. But as you just heard, the real environment might be impossible, unrealistic, or just too expensive to reach. I mean, even if this comet lander crashed in your backyard, you probably don't want it to break because it must be a very expensive machine. Therefore, I research how we can combine models that describe different parts of these very complex machines in computers so that we can catch all of these flaws before we build anything in a realistic way. So how could partial models that talk to each other help at all? Well, let me give you an example. So a chemist has designed the perfect battery, the best battery there is, according to the chemist. Then we have the electronics designer who has built electronics based on what they know about this perfect battery. But then the mechanical engineer needs to fit all of these parts into the mechanics, and maybe the electronics are too big and the battery is too heavy, and the whole process starts over. Now imagine there's not three, but 3,000 of these experts that need to collaborate, and they all have their own models of their part of the system. So in my research, I have discovered ways to create simplifications of these models so that they can share this relevant information. So for instance, the size of the battery to the mechanical engineer. But when a project is this big with so many people, not one human can keep track of this, but a computer can. So the question is, would this kind of computer-based design phase model interaction have saved our comet lander? Maybe. At least we're one step closer to building flawless machines that will not need to be repaired. Thank you.